So the next section you guys are covering on Apex is trigonometry. So there's a lot of material in this section, so we're going to kind of break it apart. What I'm going to focus on today is special right triangles, and then on next class or next video I'm going to go through some right triangle trigonometry. So it's going to sound confusing, but it's really not as bad as you think. So first thing, just a quick review of Pythagorean theorem. Most of you guys already remember this stuff. So remember, it's a right triangle if it has that little box in the center. The side that is directly across from the right angle. So if you were to take a flashlight and shine a flashlight right here, it would shine on this side right here. So that side is opposite the right angle. So that is what we call the hypotenuse. And that is always going to be the longest side and always going to be across from that right angle. Now the other two sides, we just have one name for them. We call them both the legs of the triangle. So this is one, let's use a better color there. Okay, so this is one leg, and this is the second leg. And remember, let's say I name these A, B, and C. Remember your Pythagorean theorem says if we square both sides and add them up, it will equal the hypotenuse squared. So A squared plus B squared equals C squared, where C is always the hypotenuse. So that's the one important thing. C has to be the hypotenuse. So I'm just going to do one of these for you guys. So first thing, identify which side is your hypotenuse, what's going to go on the other side of the equal sign. So these two are my legs, so I'm going to set them up. 12 squared plus 5 squared equals x squared. So whenever you are solving for a missing side and you're using this Pythagorean theorem, you're plugging it into the formula right here. And you just plug in the numbers that you have. So we're going to go ahead and finish solving this. So 12 squared is 144 plus 25 equals x squared. 144 plus 25 is 169. And then to get rid of that squared, we do the opposite, which is square rooting both sides. So the square root of 169 is 13. And because we're working with lengths or side lengths, we cannot have a negative number. So in this case, x is just going to be a 13. Let's just do one more with you guys. So in this triangle, this 5 centimeters is the hypotenuse. So when I set this up, I'm going to have 3 squared plus x squared, and then the 5 squared goes at the end. So this one has a little bit more math attached to it. You guys can see right on the screen. I'm going to subtract the 25 and the 9. And then I take the square root of both sides to get x equals 4. So that is how you want to solve a problem using your Pythagorean theorem. So always go back to that highlighted formula. So let's take a look at the next page. So over here we are going to talk about special right triangles. So there are two types of special right triangles. There's a 45-45-90 and a 30-60-90. So the first one we have here is the 45-45-90. So first thing we need to know is the two sides, the sides that are opposite those 45-degree angles. Those are going to have the same exact length. They're going to be congruent because the angles are congruent. So those two sides are going to be the same. To get our hypotenuse, we're going to take that leg and multiply by the square root of 2. So the things you need to remember are the two legs are the same. And the hypotenuse, sorry guys, my writing isn't working very well today. Okay, the hypotenuse is equal to the leg times the square root of 2. And you want to use that picture as kind of your formula for the rest of this. So for number 1 here, so these are my 2 legs. So this one is my hypotenuse, which would be a root 2. So if my side is 3, that tells me this side is already 3, this side is also 3, this side is 3 root 2. Number 2, so this one, normally there's more markings here. So you'd have something like this where the little squiggles in the corners to show that the 2 sides are the same. So my new side length is 2 root 3. So this is also 2 root 3. And remember, my hypotenuse is always going to be a root 2. So I'm going to take 2 root 3 and multiply it by root 2. Now remember, when we multiply radicals, we multiply the insides together. So I keep that 2 out front, and then on the inside I have 3 times 2, which is 6. If you could simplify that, you would. In that case, 6 can't be broken down, so we are done. Okay. And then our last one is the 30, 60, 90. So with this triangle, the most important thing is the shortest leg. The shortest leg is going to be across from the smallest angle. So I'm going to call that A again. So A is going to be the shortest leg. And then to get my long leg, I'm going to take the A and multiply it by the square root of 3. So that A root 3 is what we call the long leg. And then to get my hypotenuse, it is twice the short leg. And that is the hypotenuse. Okay, so we're just going to jump right into an example. Again, you want to use the numbers we got, or the setup that we have right here. So with this one, first identify your short leg. So 11 is my short side. So then this is my long leg, A root 3, and this is my hypotenuse, 2A. And then A is 11, so just plug that number in. So this side is 22, this side is 11 root 3. And that's all you got to do for these special rights. So let's take a look at one more. So this time, I don't have my short leg. So I like to think of these as a formula. So I have 5 root 3 is equal to my A root 3, because that's my long leg formula. So I want to get A by itself in my little mini formula here. So what I'm going to do is divide both sides by the square root of 3. I can cancel all my root 3's, so that tells me A is equal to just a plain 5. And then to get my hypotenuse, multiply that by 2. And that's how we would find our missing sides. So what I'm going to do is, I want you guys to try the rest of the examples on pages 1, 2, and 3. I'm going to put up an answer key so you guys can check those answers. And then the only thing you guys need to turn in this week is that final page. So the final page has some practice problems. It has 8 practice problems, and it's a mixture of the 2 special right triangles. So I want you guys to try those 8 problems, and that is what you have to turn in this week. If you have any questions, let me know. Like I said, next video we will talk more about the actual trigonometry stuff. Good luck.